Right now, everything you can see, this screen, your room, the sky outside, the Earth, the sun, every star you've ever looked at, all of it used to be smaller than a single grain of sand. Not small like a planet, not small like a house, smaller than a grain of sand. And it was all packed into that tiny space at the same time. Then, in a fraction of a second, it started growing. And it never stopped. That's the Big Bang. And today, we're going to explain it in plain, simple language. No confusing math, no complicated words. Just the real story of how everything began. Welcome back. I'm David. This is SciTales. Last time, we followed a visitor from another star system as it flew past our planet. Today, we're going back much further, all the way back to the very beginning of time itself. Here's what we'll cover: what the Big Bang actually was, how we know it really happened, what the universe looked like in its first few minutes, and, this is the fun part, a brand new discovery that has scientists a little confused right now, because it doesn't match what the Big Bang Theory predicted. By the end of this episode, you'll be able to explain the birth of the universe to anyone in simple words, and you'll understand exactly why scientists are excited about it again this year. Let's go. Segment 1. Let's clear up the biggest misunderstanding first. The Big Bang was not an explosion. I know it sounds like one, because of the name. But nothing blew up inside of some empty space, like a bomb going off in a room. Here's a better way to picture it. Imagine a balloon. Now imagine that balloon is completely deflated, squeezed down into the tiniest dot you can think of. Every bit of the balloon's material, all the rubber, is packed into that one dot. Now someone starts blowing air into it. The balloon doesn't move to somewhere else. It just gets bigger, everywhere, all at once. Every point on the surface moves further away from every other point. That's the closest simple picture we have for the Big Bang. About 13.8 billion years ago, all of space, not just the matter inside it, but space itself, was packed into an incredibly tiny point. Then it started expanding. And it's still expanding today, right now, as you listen to this. It wasn't stuff exploding into empty space. It was space itself, stretching out, carrying everything inside it along for the ride. And here's the part that breaks people's brains a little. There was no before. Time itself started at that same moment. Asking what happened before the Big Bang is a bit like asking, what's north of the North Pole? The question doesn't quite work, because you're standing at the very starting point of the thing you're asking about. Segment 2. This is a fair question. It happened almost 14 billion years ago. Nobody was there with a camera. So how are scientists so confident about it? Two big clues. Clue number 1. Everything in the universe is moving apart from everything else, and it's happening in every direction. Imagine you're standing in a crowd, and no matter which way you look, everyone is walking away from you and from each other, all at the same time. That only makes sense if, at some point in the past, everyone started out standing much closer together. Scientists noticed this same pattern with galaxies. Every galaxy we look at is drifting away from every other galaxy. Run that backwards in your mind, like rewinding a video, and everything gets closer and closer together the further back you go, until it all meets at a single point. That point is the Big Bang. Clue number 2 is even stranger, and it's honestly one of my favorite facts in all of science. If you build a very sensitive radio antenna and point it at any part of the sky, doesn't matter which direction, you pick up a faint hum of leftover heat. Scientists call it the cosmic microwave background. But here's the simple version. It's the leftover warmth from the Big Bang itself, still glowing faintly, everywhere, 13.8 billion years later. It's a bit like walking into a room a long time after someone baked bread in it, and the room still feels slightly warm. That leftover warmth was actually predicted by scientists years before anyone found it, and then, in 1965, two engineers in New Jersey accidentally detected it while trying to fix what they thought was noise in their equipment. It wasn't noise, it was the afterglow of creation itself. Between the galaxies moving apart and this leftover heat found in every direction, scientists became extremely confident the Big Bang really happened. Segment 3. Let's slow down and walk through what actually happened right after the beginning, because it happened unbelievably fast. In the first tiny fraction of a second, the universe went through an incredibly fast growth spurt, stretching out far bigger, far faster than anything that's happened since. After that, for the next few minutes, the universe was an unimaginably hot soup, too hot for atoms to even form. Just loose particles bouncing around everywhere. Then, around 3 minutes in, things cooled down just enough for the very first, simplest atoms to form, hydrogen, and a little bit of helium. That's it. That's the entire starting ingredient list for everything that exists. Every star, every planet, every person, all of it eventually built from those two simple ingredients, cooked further inside stars over billions of years. For a long time after that, hundreds of thousands of years, the universe was actually dark. Not empty, just dark. There was too much loose material floating around for light to travel freely through it, kind of like trying to see through thick fog. Then, around 380,000 years after the beginning, things cooled and calmed down enough for light to finally travel freely for the first time. Scientists sometimes call this moment the universe becomes clear. That very first light is actually the same leftover warmth we talked about in segment 2. We can still detect it today, in every direction, all these billions of years later. Segment 4. And here's why this topic is trending again right now, in 2026. We have a space telescope called the James Webb Space Telescope. Think of it as an enormous, incredibly powerful eye that can look back in time, because looking further away in space also means looking further back in time, since the light took longer to reach us. Scientists pointed it as far back as they could and found a galaxy that existed just 280 million years after the Big Bang. In cosmic terms, that's practically the newborn universe. A galaxy that young should be small, messy, still forming. Instead, it was bright, fully formed, far bigger and more mature than it had any right to be that early. And it wasn't a one-time fluke. Scientists have now found a whole group of these unusually bright, surprisingly grown-up galaxies from the very early universe, roughly 100 times more of them than their models expected to find. One galaxy, spotted less than 2 billion years after the Big Bang, doesn't even appear to be spinning the way young galaxies normally do. Another shows 5 galaxies already colliding and merging together far earlier than anyone predicted was possible. To be clear, none of this breaks the Big Bang itself. Nobody seriously doubts the universe started small, hot, and expanding. What it does challenge is our model of how fast stars and galaxies were able to grow up afterward. Right now, scientists are genuinely unsure whether galaxies simply formed faster than we thought, or whether there's a piece of the puzzle we're still missing entirely. That's honestly the best part of science. It's not finished. We just found out the early universe grew up faster than anyone expected, and right now, nobody fully knows why yet. Segment 5, and the last one for today. Here's the thing I want you to sit with. Every atom in your body was made from that same starting material, hydrogen, formed in the first few minutes after the Big Bang, later cooked into heavier elements inside stars, then scattered across space when those stars died. You're not just watching this story from the outside, you're made from it. 13.8 billion years ago, everything that would ever exist was packed into something smaller than a grain of sand. It has been expanding, cooling, and building itself into stars, planets, and eventually you, ever since. And it's still happening, right now. While you listen to this, let's bring it home, in plain, simple words. The Big Bang wasn't an explosion. It was space itself, expanding from an incredibly tiny starting point, about 13.8 billion years ago. We know it happened because galaxies are still moving apart, and because we can still detect the leftover warmth from that very first moment, in every direction, everywhere we look. And right now, in 2026, new telescope discoveries are showing us the early universe grew up faster than we expected, which means there's still more of this story left to discover. Science isn't a list of finished facts. It's an ongoing story, and we're all still inside it. Next episode, the speed of light. Why nothing can travel faster than it. What would actually happen if you could, and why that speed limit shapes everything else in the universe. I'm David. Thanks for listening. Stay curious.